All right, in this video, I'm going to show you how to use the gas laws in a limiting reagent kind of question. So, like I've said in class, you can't forget your stoichiometry. It's going to be important from now until the end of the semester, end of the year, and it continues into organic chemistry. So here we have a reaction that's taking place. Solid copper to oxide. So this is one of our reactants. Copper 2 oxide reacts with hydrogen gas to yield solid copper and water vapor. So that's the reaction that's taking place. Let's go ahead and write a balanced chemical equation. So copper 2 oxide means that you have copper that has a 2+ charge. Oxide has a 2- charge. So these two things will come together 1 to 1. So we have copper 2 oxide, solid, reacts with hydrogen gas. Hydrogen is a diatomic molecule, so it's H2, to yield solid copper and water vapor. So we have CuO plus H2 yields Cu plus H2O gas. Let's double check and make sure it's balanced. We have 1 copper in, 1 copper out, 1 oxygen in, 1 oxygen out, 2 hydrogens in, 2 hydrogens out. So this equation is balanced. So everything is 1 to 1. Now, let's get to the stoichiometry part of the question. If 35.5 grams of copper 2 oxide is placed into a 23-liter vessel at 225 degrees Celsius in 1 atmosphere, and it's filled with hydrogen gas, what is the theoretical yield of solid copper? So there are multiple ways that we can tell that this is a limiting reagent question. First way is I've given you the amount of one of the reactants, and I've given you information to get you the amount of the other reactant. So when you get 2 different amounts of reactants, that usually tells you that it's limiting reagent. I also ask you what is the theoretical yield. Theoretical yield also basically tells you that you're going to be looking for a limiting reactant kind of question. So in a limiting reactant kind of question, what you do is you start with each one of the reagents and then figure out how much of the product is formed in both cases and then do a comparison. So first we're going to start with the 35.5 grams of copper 2 oxide. First up, we're going to go from grams to moles, so we need the molar mass of the copper 2 oxide, 79.55 grams of copper 2 oxide in every 1 mole of copper 2 oxide. Then the balanced chemical equation tells us that 1 mole of copper 2 oxide reacts to form 1 mole of copper. Again, we're trying to figure out how much copper because we want to know the theoretical yield of the solid copper. Then 1 mole of the copper weighs 63.55 grams. So the overall amount that can be formed from 35.5 grams of the copper 2 oxide and as much hydrogen gas as you could possibly have is 28.4 grams. That's the theoretical amount that you can form from 35.5 grams of copper 2 oxide and as much hydrogen gas as you can possibly have. Now, let's figure out how much copper you can form from the amount of hydrogen we have. This one is a little bit trickier because it's a gas, and now we have a gas law equation. So just like all other gas law equations, I'm going to collect up my variables. PV equals nRT. R is the gas constant, 0.0821 liter atmospheres per mole Kelvin. Let's take a look and see. So I want to know what is the pressure of my gas. Well, we have 23 liters, that's the volume. 225 degrees Celsius, that's the temperature. 1 atmosphere is the pressure. We're trying to figure out the number of moles of hydrogen gas in this gas law equation. Now be careful. Make sure you know what you're solving for. All of this information telling us about the hydrogen gas. We're going to have to do something different or something more after we figure out how many moles of hydrogen gas we have. So make sure when you're solving your gas law equations, you know what it is of. This is of the hydrogen gas. So double check and make sure your units make sense. The gas law units tell you what all of the other units should be. So our volume is in liters, that's good. Our pressure is in atmospheres, that's good. We don't have to do any conversions. Moles is going to be moles. Kelvin temperature, Celsius temperature. We have to convert this right away. So 225 degrees Celsius plus 273.15 gives us 498.15 Kelvin. I like to rearrange the gas law in order to solve before I plug my values in. So PV equals nRT, solving for N is equal to PV over RT. Now we can plug things in. As long as you double check and make sure all of your units match what they should be, we don't have to worry about putting the units into the equation. So pressure is 1, volume is 23, gas constant 0.0821 times temperature, 498.15. The number of moles of this is 0.562 moles of hydrogen gas. Again, you've got to make sure you know what you're talking about. You solved for hydrogen gas. Keep your eyes on the prize. You want to know what is the theoretical yield of solid copper. So now we have to do stoichiometry. We have 0.562 moles of hydrogen. The balanced chemical equation tells me 1 mole of hydrogen reacts to form 1 mole of copper. And then 1 mole of copper weighs 63.55 grams, molar mass of copper. So the theoretical yield that we can get of the solid copper if we started from 0.562 moles of hydrogen and as much copper 2 oxide as we could possibly want is 35.7 grams. Okay, so now that we have the amounts of copper we can have in both cases, now we go back and analyze to figure out what the theoretical yield is. The theoretical yield is 28.4 grams of copper. This is the theoretical yield. You can't make more than 28.4 grams because the copper 2 oxide is the limiting reagent.